Welcome to Data Skeptic, a podcast exploring the methods, use cases, and consequences of recommender systems. Welcome to another installment of Data Skeptic Recommender Systems. You know, recommender systems wouldn't be worth anything if there wasn't user feedback. That's essentially the cold start problem, and while there's some ways to mitigate the cold start problem, those all seem to end up requiring, again, user feedback. Now, your classic form of user feedback is a rating. I always liked the stars. I thought 5 things are more expressive. But I've been led to believe, and I haven't checked this for myself, but I've seen papers that seem to imply a simple thumbs up, thumbs down system has just about the same information content as 5 stars. But it all comes down to a click. The user has to select something for feedback to be gathered. Or do they? You know, the iPhone is rolling out some new technology for eye tracking, and it stands to reason all other handset manufacturers will follow suit. Should the public want it, our devices can now easily track our eye gaze. Or at least that's coming up on the horizon fast. Luckily, there's lots of researchers like the one we're going to hear from today who've been looking into eye tracking technology. Using it, Santiago, our guest today, and his team have gathered data on exactly what people look at when browsing recommendation interfaces. We talk about that classic Netflix-style layout where there's rows of seemingly related things, and then if you're kind of done with that row, you can go to the next. Of course, we see that format in lots of places, so these insights probably generalize pretty well. Well, without further ado, let's learn about eye tracking and recommender systems.
My name is Santiago de Leon Martinez, and I'm a Spanish-American researcher at the Kempelin Institute of Intelligent Technologies and also Brno University of Technology. And I'm also an MSCA doctoral student, part of the Eyes for ICU doctoral network, and I'm just about wrapping up my PhD.
Can you share a few details on what the focus of your PhD is?
So my doctoral network that I'm part of is an eye tracking network mixing psychologists and computer scientists. And my doctoral topic in general, because it's funded by the EU through these prestigious doctoral networks, it has to be somewhat related to eye tracking. But originally when I started, I wasn't as familiar with eye tracking. But I'm an AI researcher, and I focus on implementing and using eye tracking to build better informed recommender systems.
It's not often I speak to someone that's in a close collaboration with psychologists from like a computer science AI background. Can you talk a little bit about the collaboration?
Within the consortium itself, I've published a paper, for example, with a group from the University of Brno, and they're a bunch of just pure research psychologists, where we use pupil data to predict lying in a specific kind of psychological card game that they had, where they have to bluff and do these different things. I'm not a psychologist myself, but I am a psychiatric researcher, and I have many publications in psychiatry, pure psychiatry, as well as being an AI researcher. And I continue doing this psychiatric research that I used to do. When I first originally moved to Europe, I did my master's in Spain at the University of Carlos III in Madrid. And there I joined a AI research group in the university, and then was also a clinical researcher in psychiatry, part of the Jimenez Diaz Foundation University Hospital, which is the largest private chain hospital within Madrid. So we have a huge catchment area of patients. And so I kind of really started out with this journey, like mixing psychiatry and AI and trying to understand people through data, but particularly psychiatric patients. So I have quite a bit of experience with that.
Well, eye tracking is something, one of the appeals of it is I think people intuitively get what you mean, but I don't know that everyone has hands-on experience having their eyes tracked or looking at eye tracking data. Can you share a few details about the mechanics? What data do you capture?
Eye tracking, when it gets down to what you capture, is what we call as gaze. So gaze is the raw eye tracking data. And like in the simplest terms possible, what gaze is an XY position on the screen that someone is looking at with a timestamp. When it comes to this raw data, which is called gaze, we tend to process it in certain different ways because your eyes actually move like a ridiculously very, very fast. And eye trackers tend to be like something like 90 hertz or higher. They can be 60 hertz, maybe minimum, but like they tend to be 90 hertz or higher. So the amount of data that you gather of this raw gaze data is just absurd. Like for it to be like humanly intelligible in some way, you have to process it in some way. And we usually do that through fixations and saccades. So a fixation is what we classify as a set moment when someone is looking at a certain region within a certain time window. That's effectively how you calculate. There are many different ways within the eye tracking research to like calculate fixations. You can do it through velocity thresholds or different distance things, but in general, what it boils down to is like these are the areas in the eye tracking data, which is this huge amount of like sequential data that we've narrowed down to say like, oh, this for sure we know someone's looking at this point or this kind of small area. What is classically done with fixation data is you filter it above 100 milliseconds. So anything below 100 milliseconds, you say it's not related to like a cognitive process because it's like just too fast for your brain to really process it. So that's kind of like the basics of eye tracking data and what you do to kind of process it and start to get an idea. But even then, when you have the fixations, it's very hard to, if you were to like look at the data sheet, it's still absurd. Like it's not very humanly intelligible. So we start to overlay it with pictures and do different types of processing so we can try to, draw the narrative out and figure out how people, in my case, are interacting with a carousel or a Netflix-like interface.
Well, in the context of like an experiment, like you're going to put movie posters on the screen, I have n number of rectangles. And it seems like, maybe in that case you'd get, well, certainly cleaner data, but how noisy does it remain? I don't think the human eye is as consistent as maybe we'd hope to get really clean data. Do you have clear indications that are sort of straightforward when you look and say like, oh, they looked at this movie poster for this amount of time, or is there still a lot of the eyes darting out in random directions?
There for sure is still some times where you have fixations on what we would say like background or non-AOIs. So we refer to AOIs as areas of interest. And those would be like the movie posters in Netflix, like if we're talking about that. There are still fixations on the background or non-AOIs. And in general, we tend to just like kind of throw them out. But you can still easily process the data and aggregate it to get like kind of these durations. When you look at it like purely sequentially, it's very hard to understand like as a human. That's why you do these aggregations on a lot of things, or you overlay the eye tracking data over like the image of what the web page looks like. And then actually the main thing that requires a lot of work is linking kind of the XY interface position or Chrome page elements positions with the actual eye tracking data. So then you can automatically process the eye tracking data and knowing this fixation was associated exactly with this movie poster because you have the XY bounding box of the interface movie poster, right? So that requires a lot of work. It definitely can be done, and it gives you a lot of very rich and powerful information to start to work with to figure out how people browse these type of interfaces.
Well, I obviously want to focus on recommender systems as the use case for most of our conversation, but before we jump right in, could you share some details on what you've learned about in terms of other popular use cases of eye tracking outside of recommender systems? What do people use this technology for?
From the researchers that I know from my consortium, there's people that work a lot on understanding how eye tracking in autonomous drivers. Sorry, not autonomous drivers, but learning how people drive and professional drivers. So in this case, they have like a lot of experiments or even construction workers that are trying to do like a tractor or these different type of things, or pilots and airplanes, all these different type of like professionals that learn how to, through like years, learn the expertise of how to like figure out this machine. And for example, in an airplane, you have a bunch of like dials and things that you have to constantly look at. And there's a lot of eye tracking studies, particularly my colleagues in psychology, like look at how does a expert like look at all the dials and all the different things in an airplane versus someone that's a novice. And effectively, like experts start to learn like tricks and shortcuts and like repeating patterns that they do to like look at these certain areas of the airplane to check that everything is going, while the novice like kind of freaks out or maybe takes longer. He doesn't have these patterns and all these different things. So that's one example. There's a lot of other researchers within the consortium work on trying to understand saliency. So how particular things can draw your attention in images. And this even is done with a lot of computer vision and AI techniques, where you have like deep neural networks that learn saliency. This is not something I've done with my research, but it's a possible like future direction as well of trying to understand how, for example, in a recommender system, whether positional bias of like where you place the item within the interface, if that's actually stronger than the visual bias. If we're particularly talking about like movie posters or even like on Amazon Marketplace, like how good the picture is of the lawnmower. And it's hard to say. From my knowledge, there is no paper that has looked at the comparison of like what is more important, the positional bias or the visual bias. We know both of these things are very important, but there's no paper that really compares them and really says like, oh, this might actually be more important. It's a very interesting research question.
Well, what are the applications for eye tracking in recommender systems?
So that's exactly what my focus is on. I focus particularly on carousel interfaces, which are the Netflix-like interface. And my main idea is to take eye tracking. So on the first step that you can do is when you like eye track people that use recommender systems, you can start to understand how they browse. And so just based on the insights that you get from the eye tracking analysis, you can start to get an idea of how like people sequentially browse the different items, and that can really inform your recommender system. So one of the papers that I published within SIGIR in 2025 presents results like the first eye tracking study within carousel interfaces. And here already, it started to hint at a result that I found in a later paper that is being under review right now. But effectively, what the eye tracking analysis shows is that within this Netflix interface, when you are first looking at the first page of items before swiping, so like imagine you open up the homepage of Netflix and you can swipe each of the horizontal lists to see more items or not. After swiping on the right side, people don't start back on the left. They stay on the right and they browse right, left, rather than left, right. So the normal traditional assumption within a recommender system, how you position your ranked items, on the first page, it's one from starting from the left to right. It's 1, 2, 3, 4, 5, maybe 6. We say there's 6 items. And then you swipe right, and then it goes back to the far left, and that would be the 7th, 8th, 9th, and 10th, 11th, 12th. However, the eye tracking studies shows that people initially browse starting on the right side. So that actually gives a strong argument for considering, at least, you don't have to, but like it's worth considering flipping that ordering on all of the swiped interface pages.
So are you saying that we don't read like typewriters, we read more like snakes and starting from the right?
Yeah, exactly. Usually we would read left, right, like a typewriter over and over again. But when it comes to these carousels that we swipe, you keep your eyes like kind of close to where the mouse is. And since you swipe to the right side, this is on desktop interface, you keep your eyes on that same right position. And then you start from there and then you would go left.
Interesting. That's somewhat surprising. Do you find it to be surprising, and do you have an intuitive understanding of why it's like that?
I think it is surprising, but it's not crazy. It's not like out of this world, right? And I think the intuitive understanding is that you have this mouse cursor that draws people's attention, and they're more likely, since you purposefully move the mouse to the right side to go click the carousel to like swipe and see the next items, that kind of draws your attention there. And then you just kind of like let them slide in and you look at the same point that you were looking at before. Yeah, and it's probably the mouse or something like that, that you're just like keeping your attention in the same place. Because if you were to like kind of drag your eyes with it, like it moves pretty quickly, like you don't see it fast enough. So people start from that kind of same position.
And this is sort of out of scope from your work, but I'm just curious, or maybe you could comment on who your subjects were in the experiment. But in different languages, I know they sometimes read right to left versus me as an English-only reader, I read left to right. Did you have to account for that at all, or were you just working with maybe English-only speakers?
The study was done in Amsterdam and in Slovakia, like European countries where people read from left to right. So it's something we considered, and absolutely like an eye tracking study of how people would behave in countries, particularly in Asia, where they read right left. It would have to be very different, right? But at least for like left right readers, we think this applies to them.
Are there any other maybe nuggets of wisdom or efficient summaries you have from that about the way people browse? Like, My personal experience is I think I kind of look at a row and then maybe I'll decide if I'm going to skip to the next row or not and then scan like that. I don't really do vertical scans myself, but do you have any other insights along those lines of what typical people do?
Yeah, like I said, there's a whole paper on this. It's called Writing the Carousel. It's on arXiv, and I'm resubmitting it currently to a conference. And I have a bunch of summaries there. But the whole kind of summary of the results that I found is that people browse from the far right side. So if you do a vertical transition, so if you go from one list to the next one, you're either going to do it from either of the ends, the left or the right end. So that's one thing. So people transition very rarely from the middle movies. So that's one thing. So what I'd mentioned about the swiping behavior afterwards, that's probably the biggest result that considers switching the ranking order. When you look at the empirical fixation data, the amount of fixation, the amount of times someone is looking at a certain movie, we actually get a different result if you wanted to base your rankings on that. Interestingly enough, there is the second to last movie on the right side is slightly fixated more than the last furthest right movie. So that's another kind of interesting result that kind of probably needs more eye tracking studies to follow up on and really confirm this. But that's at least what we saw through our data set. And the other results would be that we found there was a significant top two row bias. So the initial kind of top two rows that are shown in the interface are definitely seen more and fixated more compared to the other rows. This is kind of like an idea that, for example, if you have some sort of business constraint and you have some ad or something, or you want to put your own materials, maybe it's worth putting in the top two rows, or just to get an idea. These are probably the most important two carousels that you're going to have within the interface. Another thing that we found is that row skipping, so completely skipping a particular row and not looking at any of the movies in it, is very rare. That's another thing as well. So people may be kind of looking at the topics and finding which topics that they like or not, but they tend to at least look at least a few movies in to each of the topics. And then finally, we also have preference information from our users. And to no one's surprise, the topic preference, which we gathered beforehand from a pre-survey, is definitely very impactful on their browsing. So people are more likely, statistically significant way, to browse towards areas where that are in line with their preference metrics, whether that's from rating or their top genre, or preferred versus non-preferred, these metrics that we take, that was seen across that.
Well, in a lot of the recommender systems applications that I've interviewed people about, most of what they have to go on is just click-through rate data. So you display a bunch of items. There's no information to them about what people dwelled on or looked at. All you know is which one they happen to click on, which is it's a good measurement. It's what you've got, and it clearly is some level of intentionality you're measuring from the user, but it's much less rich than the data you have access to. How do you leverage that information to make a better recommender system?
Yeah, so one of the biggest things that you can even start to see from this data and how people browse is that people browse very differently. And that gives you an idea that how you position items within the interface, or what we call as positional bias, is super relevant. Not only is it's particularly relevant when we're talking about complex interfaces like carousels or like Netflix, because you have initial kind of lists or carousels that are shown that you have to scroll. That's a costly action to scroll vertically down to see more. It's also somewhat of a costly action to swipe to see more movies even within the same list, right? And the idea here is that all of these different positional, how you decide which movies you decide to show, is already completely biasing the click that you're going to get, right? You can find the most relevant for a certain query or the homepage or whatever. You can find the best movie for a user. But if it's at the bottom and you have to swipe a few times, the bottom carousel, they might never see it, right? And this is also related to, there's been also big research in impressions. And impressions is not only clicks, but mixing the clicks with the idea that it was shown on the viewport or the interface to give kind of some sort of idea if it was seen or not. Well, eye tracking is the next level. it's even richer than impressions. Like we know exactly which things were looked at on the screen. And even if you want to start to play with the idea of duration or how someone's looking at it, how many times they look at it to infer intent or attraction, you can start to do that as well. I will say that when it comes to intent prediction or like attraction prediction in eye tracking, outside of recommender systems, there's some works in recommender systems, but like outside of recommender systems in the eye tracking research world, it's actually like a very difficult problem and it's not so simple. I personally don't work on that because how long someone looks at a certain item, it can be up to so many different things. And like contextually speaking, it can be up to the user in different ways. You could stare at an item because a particular movie poster because, I don't know, it looks super awesome. It looks like a very cool action movie, or maybe it looks terrible. Like maybe it looks so bad that it draws your attention to it and you're like, wow, this movie is really bad. It's garbage. So how do you kind of distinguish between those two scenarios? And it can be a lot of different things and it could be completely dependent on the user. So I think that part is a very interesting research question, but very hard, very hard. Although I do have one work of using gaze data for implicit feedback. So using like how long people looked at it in a collaborative filtering model and at a particular item or movie. And you add those in as like positive feedback. It helped the collaborative filtering model a bit with the recommendations. It did improve the recommendations of the users. But I think this is something that probably needs to be studied quite a bit more. And it's probably very difficult. I think when it comes to the sense that if we have consumer grade eye tracking technology, whether that's like the front facing iPhone, which I don't know if you know from the iOS 18, you can be eye tracked with the front facing camera of the iPhone. So it does work. So it can be gathered technically. But if we get to the world like where everyone's using some VR headset, then we will have access to eye tracking data always. And in this case, you can start to build neural networks that are taking this sequential data and start to learn these and like rip out these patterns from a bunch of different users. And I think then it starts to get feasible to really understand intention and attraction in some way, or at least the neural network can start to figure it out a bit. But as humans, it's quite difficult. It's like too much data.
Well, maybe this reflects my age and when I was in grad school, but my first instinct is, hey, we have to featureize this data set. Let's calculate dwell times or like the count of times they looked back at something or the order. But what you're suggesting with the neural network is maybe throw it into the machine and let it figure it out for itself. What's your perspective on how to use the data?
So in terms of the data, we have a data set released and it's publicly available for research if you'd like to use it. And it's summarized in pretty much what you said. So like all of the fixations are aggregated within and are marked to certain AOIs or movie posters. So you know like the item idea, how long it was gazed at, or how long it was fixated at, the duration. And you have like this summarized across all the screens for all the users, as well as you have like some extra user information, the item information. The cursor movements are also included in this data set, as well as like a selection explanation as to why people selected this movie, how familiar they were with the movie, and then like why they selected it. So it could be because of the poster, because of the details, all these different things. So this is all included in the data set and it's available for people to play with. And part of the reason is because there is no eye tracking recommender data sets to date. And I wanted to work on this and I realized, okay, there's nothing. So I have to do this. I'm going to have to do the user study. And I would like in the future, if anyone wanted to work on this, like they also can do it as well. And I generally believe that we're tending to kind of this future where it's definitely possible that a recommender system has kind of like online eye tracking data. But when it comes to like what you were saying in the sense of, yeah, you can get dwell times for things. And I think there should be some human oversight, like looking at like eye tracking data a bit, and there'll probably be people, that work on this a lot. But I think it just starts to get very difficult. And that's why I'm leaning more towards kind of like a deeper neural network approach to really trying to figure out these type of things. It's just the data is like really, really massive. It's just like a very rich sequential data. And when it comes to like being able to understand as human, it's just too much.
Delete Me makes it easy, quick, and safe to remove your personal data online at a time when surveillance and data breaches are common enough to make everyone vulnerable. Do you think your data is private? Think again. Data brokers make a profit off your data every single day. Your private details are being bought and sold on the web. The New York Times Wirecutter has named Delete Me their top pick for data removal services, and for good reason. Delete Me's privacy experts do the hard work for you, removing your information from hundreds of data broker websites and sending you personalized reports showing what they found, where they found it, and what they removed. Have you been the victim of identity theft? Maybe harassment or doxing? If you haven't, you probably know someone who has. I certainly do, and that's why I take my online privacy seriously. Using Delete Me has helped me minimize the amount of personal information available to strangers online. It's one of the smartest steps I've taken to help protect myself in this digital age. Take control of your data and keep your private life private by signing up for Delete Me, now at a special discount for our listeners. Get 20% off of your Delete Me plan when you go to joindeleteme.com/data and use the promo code DATA at checkout. The only way to get the 20% off is to go to joindeleteme.com/data and enter code DATA at the checkout. That's joindeleteme.com/data, code DATA. Thanks to this week's sponsor, Zapier. These days it feels like everyone is talking about AI, including us here at Data Skeptic. But if there's one thing you've learned from this show, it's that talking about a new technology isn't the same thing as implementing it. And honestly, AI has already changed how I work. I haven't written a line of code in at least 3 months. I just speak it into existence now. It's not just about speed, it's about what becomes possible when you can offload the tedious stuff and focus on the creative problem solving. But here's the thing. The real power comes when you can integrate AI into your actual workflows, not just use it in isolation. That's where Zapier comes in. Zapier is where tech innovators break the hype cycle and put AI to work for real. I've been using Zapier for at least a decade, and it just keeps getting better. What I love most is how easy it is to incorporate into your workflow. You don't need to be a developer or to wait for IT approval. We use it for podcast production, handling marketing campaigns. It's popular for sales pipelines and HR processes. Zapier fits right in. We're building automations that can handle everything from moving audio files between cloud storage to managing our content calendar and routing new business inquiries to the right team member. So what is Zapier exactly? It's an AI orchestration platform that lets you bring the power of AI to any workflow. You can connect top AI models like ChatGPT and Claude to the tools your team is already using, so you can add AI exactly where it needs to be. Teams have already automated over 300 million AI tasks using Zapier. Are you ready to join them? Get started for free by visiting zapier.com/dataskeptic. I'm going to spell it for you. That's Zapier, zapier.com/dataskeptic. Well, I don't know that we named it, but I think we were discussing the RecGaze dataset, which is really pioneering in this area. As you said, I don't know of any other, so that's a good motivation to release it. For other researchers who might be in this space and are thinking about using the dataset, can you describe a little bit about its contents?
So the RecGaze dataset is the first eye tracking dataset within recommender systems, and it's the third feedback dataset, click feedback dataset available for carousel interfaces, at least publicly available. And I would also say it's like kind of the first like super extensive recommender dataset because it also includes like all the cursor movements. So you know when like you have the timestamps of like when the cursor was on something as well as when their eyes were on it. And like also when the click events happen. So all of this, you have like all this timestamped information, as well as including like user features like age, gender, the genre preferences that we get from a pre-survey beforehand, some other questions on like expertise of how often they use interfaces like Netflix, and then item features as well. You can get like recover all the descriptions of the movies, as well as IMDb scores if you'd like. But the main thing is kind of like this gaze data plus the cursors plus the clicks. That is just a very complete data set. And then if you're interested in as well, like why people pick this particular movie.
Well, I think what you're describing then would be sort of a hybrid system that would tie in all of these features, like I don't know that eye tracking alone can build a recommender system, but eye tracking plus collaborative filtering is probably better than just collaborative filtering alone. Curious to hear your opinion on it and maybe how you integrate these systems.
Yeah, so like what we were talking about before, when it comes to like actually using the eye tracking data as feedback and plugging it into a model, I think that's like kind of the step in the future a bit that we kind of need neural networks for that. I try to do something simpler first, right? And the idea is the first step is like we have this eye tracking data, we process it, and we try to like get human like insights as a researcher looking at the data at how we should design the interface itself and maybe where we should place our items. So the first kind of result that we got from that, what I mentioned before, is that maybe we should consider ranking differently after swiping these carousels. So that's the first thing. It's like human insights, right? That you can then program as an engineer, as a recommender systems engineer, into your system that make more sense. And I think one of the big problems when it comes to research as well in practice for recommender systems are like very complex, and we make like a lot of assumptions here and there that actually add up quite a bit. And as things have started to get more complicated, it's more and more likely that these assumptions are wrong. So back in the day, we only had like search engine results pages, and people assume that people browse top down. Well, that's actually a fair assumption because it's pretty much how the page is set up, and there's not much else to do. But we still did eye tracking studies, and we confirmed it empirically, which is important for the scientific process. And things started progressing. Then there's like the Google image search results. That starts to get a little bit more complicated, but maybe you assume left, right. However, there are eye tracking studies that show that there's kind of like this F pattern behavior on these grids, meaning that people are more likely to hit the left side and go further right when they're in the top, so like in an F, right? And as they go further and further down, they're less likely to branch off in this F, right? To go right. There's another eye tracking study particularly with images that shows that there's like a center bias as well. So that's another possibility for kind of grid setups. And usually you'd make the assumption that like you read left, right? But it's not too crazy or anything. But it could be a flawed assumption that effectively like takes a huge hit on performance on your recommender system. Like you have the greatest recommender system possible that gives perfect relevance, but you put the items in the wrong place, you messed it up, right? It doesn't matter how good your algorithm is if you're putting the items in the wrong place. So that's why it's kind of nice to do these empirical studies, particularly by tracking, to really understand how people browse.
Well, I know most movie posters, they're similar. They're all trying to do the same thing, let you know what's in the film a little bit. There's variety, but not insane variety. If there was, I could see where maybe a movie poster that's all text, maybe my eyes would dwell there longer because I'm reading it or something like that. And I'm sure at least one movie poster in the world exists like that, even if it's not common. But do you have concerns like that there could be something almost spammy about a movie poster that would draw more gaze than perhaps is a true conveyance of the user's interest?
Yeah, for sure. That's like definitely a big limitation to like our study and even the data set. And it's something that we recognize. Most our eye tracking results are done through aggregate across like every participant does multiple screens. They do 30 screens of free browsing, and we aggregate all the eye tracking results across them. So it's definitely possible that visual bias of a particular poster being either like super attractive for some reason that it's really calling to the particular participant, or kind of what you mentioned in the sense that maybe if it was like all text, it's maybe not the most attractive movie poster, I would say, like from the get-go, but being kind of the ugly duckling, maybe it draws your attention to it, right?
Could be.
Yeah.
And could you describe the experimental setup a little bit? If I had been one of your participants, what would I have gone through in the data collection process?
Yeah, so you would have either been in Amsterdam or in Bratislava in Slovakia at our institutes, and you would have came in. We would give you kind of like a pre-survey at the beginning. This is where we get all your genre preference information, your age, gender, these type of things as well, like the user information. And you kind of sit down in front of a laptop with an eye tracker. And an eye tracker is like these little bar eye trackers that you put at the bottom of the screen. And it effectively just like looks at you and will gather kind of these XY positions linked to the computer screen. And you just kind of sit there and do an environment that we made that's as close as possible that we could get to Netflix, without infringing on copyright. And the idea is that like Netflix is like the most well-known standard kind of like movie interface. And if you look at like Prime Video or Hulu or something, they're all kind of carousel interface and they're all pretty much like Netflix. So we just opted for Netflix. You just kind of sit there. Most people take like about an hour to go through a bunch of screens where they're just picking a movie that they would like to see amongst like all the ones available. There's 150 available on each screen, and they pick a movie they'd like to see. That's the free browsing task. We have some additional tasks as well to be able to relate how, for example, a user might, based off of a different task, they might search differently. And there's a direct search task. For example, this is like we tell them to find a particular movie in a particular genre. So that gives you an idea to be able to compare how these behaviors may be slightly different. And finally, there's a third task. It's called the semi-free browsing is what we call it. And it's find a movie that you would like to watch within your favorite genre. So it's this free browsing, but limited to your favorite genre, which you marked on the pre-survey.
I don't know that I have shared this opinion, but people have strong privacy concerns. I don't think most people would want the camera to come on while they're browsing their Netflix feed, but maybe there's an argument for it. If that can improve my overall Netflix or YouTube experience or whatever it is, maybe I would want to opt in. What are your feelings on the privacy aspects of this?
Yeah, that's a really good question. I think ethically and like privacy wise, it starts to get very complicated because we don't kind of consciously control our eyes. When we get to the point where people are like eye tracked constantly, you can start to figure things out about them that they're not even like that conscious about either. And it reveals so much information about you, like semi-consciously or even consciously, that you may not even know about that it can be pretty crazy. There's other things as well, like with eye tracking data, some people are working on trying to diagnose Alzheimer's, all these different things. So like based on your eye tracking data from Netflix, if it were to get released or something, someone can try to diagnose you with that, with some sort of mental illness or something like that, right? And I don't think people are happy with that.
Huh. I feel like at the right age, I would want to opt in and have my phone warn me, hey, speak to a doctor, you're showing.
Yeah, that's fair. That's fair.
Right.
With consent, you knew what you're getting into, right? Like you knew what you're getting into. But yeah, if you're just normally using Netflix and Netflix is figuring out like every single thing that you exactly like more than like you even know, that's almost sounds kind of creepy, right?
Yeah. I mean, it wouldn't surprise me to find out that a future study determined that through RecGaze data, you could determine someone's romantic preferences. Maybe that's science fiction, but it seems quite plausible. We could also take it a little bit sci-fi. I don't think it can, like you mentioned earlier, maybe it can detect lying, although that's, I know traditional lie detector machines are not science. Maybe the eye tracking lie detector is. What are the limits here?
I think, to be honest, we don't know the limits. Eye tracking research it's been done for a few years now, but the technology keeps getting better and better. And we haven't been to the point where we have like an online system that is constantly eye tracking, where you can start to, like I said, plug in some sort of very sophisticated model to start to figure things out, like really figure things out. But like you said, when it comes to attraction or sexuality, it's possible that like your eyes can really reveal this based on these posters of like seeing, whatever gender you like or attractive people, these type of things. It's definitely possible that the eye tracking data could completely reveal that. And I don't think most people would like Netflix or like kind of these companies without knowingly telling them your personal information, right? Like for that to be out there, particularly when it comes, to their sexuality or these different things. I think that's very private and personal. So I think people would probably be kind of scared about that. But there also comes a sense, like you said, that if these things integrate very easily into your life and it makes the system so much better, it may be possible like that this kind of practicality of it kind of overweights it. And that's the same thing when it comes to cell phones, for example. Like previously in my master's with my psychiatric work with ML stuff, we did data scraping of psychiatric patients from their phones to get their step data, their sleep data, everything. And we do this to do like change point detection to see if they're getting better or worse during a certain treatment, and possibly, even diagnose some sort of mental illness or problem that they have. But effectively, like data is like a biomarker for someone. Someone can be represented through the countless amount of data that they generate throughout the day with their cell phone and all these different things. And I think once you start like really getting access to a bunch of that, you can start to like nail people down and identify them and figure out things about them that they probably could be kind of, worried about, right?
Again, out of scope, but just curious to get your thoughts. Is my own eye tracking data unique like a fingerprint?
It is. It is, yeah.
Interesting.
Particularly the most dangerous thing when it comes to eye tracking data is your pupil data. The data set that I have, it doesn't have any pupil data on purpose because it's publicly released and it's also anonymized in a way to protect the identity. And there's like consent and everything from all the participants. They know, that this is going to be made into a data set. But pupil data is very dangerous in the sense those micro movements that your pupil makes can identify you. Just like, for example, there's also research in very high frequency, accurate data about your heartbeat can also identify you.
Fascinating.
Yeah, everyone's heart, like in general, kind of works the same, but there's slight differences and maybe the volumes and all these different things. You can figure things out with a very sophisticated model. Yeah.
Well, I was going to ask you what you'd recommend if Netflix hired you. I'm going to switch that to YouTube because in my personal experience, they have the most room for improvement on their video recommendations. If they were to take your findings seriously and brought you on board, what would be the key advice you would give them?
Like I'd mentioned before, the most important thing that my research is kind of focused on outside of the eye tracking is like, let's start to question the assumptions that we make when we're designing a recommender system, like the basic assumptions that we make about a user. Let's question those and like, let's try to figure out if they actually make sense and how we position the items from the get-go. That's one thing. And really what my research is transitioning now is actually simulating users. So eye tracking and clicks and all these different things, you can build user models or click models, these different things to try to represent a user. And the simulation of users, when you just have clicks, it's kind of hard to really understand someone. So you need to like get the information, whether their preference, these different things, the different context. But eye tracking as well starts to give you like a rich amount of data to be able to simulate a user and create more realistic users. The problem is like nowadays in the digital age that we live in, we have so much data. That's not the problem. I think previously, like maybe 20 years ago, we were like, we need more data. We need more data. Now we have an absurd amount of data. Now we need to get good data and we need to figure out how to filter it or, what they're doing with all these tricks with LLMs to get them to work better and better. It's about getting the right data. And when it comes to recommender systems now, I think it's about making like the correct simple assumptions from the beginning and then also trying to get good data. And one of the possible ways is to simulate users correctly. And this can be done through like, particularly when you get multimodal rich data that represents a user, whether it's from like the cursor, as well as the clicks, as well as the eye movements and their preference information, all these different things. So that's kind of the direction I'm going towards now.
Could you share a few details about that simulation process? At its rudimentary level, I guess you could make random XYs, but that's probably not helpful. How do you model the richness of a true person's gaze changes?
Yeah, so modeling like actual gaze data, this is like a very recent topic. Well, it's been worked on for many years, but only recently have researchers really been able to correctly regenerate, like simulate gaze data. And this is from a paper from the University of Stuttgart, Andreas Bulling's research group. They recently were able to like regenerate, I think, gaze data for biometrics for what we mentioned for like security, like, being able to tell a certain person how they look at something and identify them based on that is, I think it's the first time that they had a deep learning method that like successfully was able to kind of like trick it. And actually re-simulating the gaze data, that's like a very, very hard problem. I work particularly more on kind of re-simulating the click, which is simpler. Yeah.
Makes sense.
I think it's very interesting. I think how you would try to kind of build like how someone observes the page. But as you'd mentioned before, one of the problems is that like people like look in weird places. You don't even know why. And how do you simulate this? Sure, you can do like add noise. You can do a Bayesian, some sort of probabilistic process of like They may do something weird, something like this, but it's very, very hard to model, I think.
Well, the classic problem in recommender systems is the cold start problem, that a user shows up, you've got no information. How do you possibly make a good recommendation? Even once you get your first click, what does one click tell you? It takes a couple of clicks at least. But it occurs to me the eye tracking data could be very beneficial to that cold start problem. Would you agree?
So like a cold start user, you have no eye tracking data of them, correct?
At second zero, that at t equals time is zero, you have no data. But with eye tracking, you start acquiring data a lot more quickly than you would with just click data.
Yeah. So in that case, yes. If you're talking about like even before the click, there's like how someone observes already, that is like a rich amount of data. That's when we're starting to talk about like maybe a recommender system that I said that's a deep approach that would start to look in an online way. So you're browsing Netflix, and one way, so the carousels or these lists are pre-generated by Netflix. And from my understanding, every company pre-generates it for that particular user in that context. But once you have an online like eye tracker and you have this eye tracking data just flowing into the model, why don't you generate the recommendations based off of how long they're looking at a certain movie poster? It makes perfect sense, right? So in that type of scenario, I completely agree with you. When it comes to like the true cold start, you don't even have like any eye tracking data on that user or anything, like true time zero. Probably the eye tracking data just allows you to get richer models of the other users, where you get an idea that the collaborative filtering works more effectively because you built a better user model of the other users. You're able to maybe try to relate it to kind of these richer models that you have of the other users, and you'll probably get a better fit that way.
One of the papers we've been talking about focus on movie recommendations in this carousel style, but it's not the only place that style can exist. It could be in e-commerce or things like that too. Do you think your results will translate there seamlessly?
That's an excellent question. Yeah, like there's probably a big difference between the context and kind of the intent of like being on an e-commerce site and a movie site. I wouldn't be surprised if this idea of how like someone browses and after you swipe and you start left right and then you swipe and then you go right left, I wouldn't be surprised if that's kind of on a desktop interface with a mouse, I should say, if that is consistent across all different types of domains and different types of interfaces where you can have like 10 carousels and like you can swipe 5 times or 3 times. I wouldn't be surprised if that's consistent. There need to be more studies really to follow up and to know for sure. I would guess that that's switching from left right to right left after swipe, that's consistent. But how people browse when it comes to like movies versus this kind of e-commerce, I think it starts to change quite a bit, because like exploration for like entertainment purposes is very different than exploration for like a very concrete thing. Like you open up Amazon because you want to buy a lawnmower, you're not doing it for fun. Your exploration is limited in some way because it's like very task driven, very specific. You don't want to waste that much time like looking for a lawnmower, right?
Well, you and I shop the same, but not everyone's like that. Yeah.
Yeah, that's true. That's true.
How important is the debiasing of clicks in recommender systems?
So I haven't worked in industry yet. I do have an industry partner that I work with a bit, but I'm not super experienced. I've talked to a few people. My understanding is that it definitely like helps the metrics, like doing some sort of positional debiasing, so upweighting and downweighting based off of like where that item was positioned. I'm not sure like how impactful it is. I know it's most helpful for offline evaluation when you're trying to we're talking about like almost simulating what someone would do with like a different policy or with contextual bandits, all these different things. Doing some sort of debiasing is huge when you're particularly doing off policy evaluation. In this case, it's like very important, or you get like crazy results. It helps a lot with that. When it comes to the actual data, I believe people in the industry do like softer kind of positional debiasing things. From my understanding, I think it's most helpful when it comes to offline evaluation.
Well, we touched on this a little bit, but I definitely want to ask, what's the future for you? Where is your work headed?
So right now I'm wrapping up my PhD and I'm looking at different kind of like internship positions, possibly maybe at Netflix, and because my topic is kind of in line with that. And I'm looking to work in industry research. So I've been an academic researcher since I was 15 years old. I started in the University of Kentucky doing like research, and I've done a lot of research from chemistry, physics, neurobiology, and I've been like a researcher my whole life. So I still love research and I want to continue doing it, but I think I want to try like a different atmosphere and a different environment than academia to kind of see what I like and figure it out, and also help me grow as a researcher.
And what's the future for the RecGaze dataset?
I hope that the RecGaze dataset will be kind of the first dataset that people go to that are really interested in trying to really understand how people browse, maybe simulating users, or as these eye trackers get better and better, and the companies start to get like a bunch of gaze data that everyday users are getting eye tracked. The problem is like these companies are probably not going to want to share this data with researchers, like academic researchers, then they'll probably be incentivized not to. It's like a very private thing. So, but it will be a struggle for like researchers to be able to play with this and try to figure things out. So if you're interested in what I call gaze-based recommender systems, these are recommender systems that use the actual gaze as like an input to the model as a feedback, then you should definitely look at the RecGaze dataset. Or if you're interested in gaze-informed recommender systems, this is instead like what I was mentioning of building user simulators, user models, or using the insights that you find from the eye tracking data to build a better recommender system yourself, then that's also a great approach.
And is there anywhere listeners can follow you and your work online?
Yeah, so you can find me on ResearchGate and LinkedIn. Those are the two main places. And also on Google Scholar, you can always follow my works.
For sure, we'll have some links in the show notes for all of the above. Santiago, thank you so much for taking the time to come on and share your work.
Yeah, thank you so much, Kyle. I really appreciate it. It was a nice chat with you.
Definitely.